Here is my recording of the key for Class E. I apologize if I sound kind of stopped up, but I woke up this morning with a really nasty head cold. So if I start sneezing, at least you know that there's a lot of distance between us and I'm not getting you sick. So let's take a look at number 1, which is a piecewise function. If you look at the 3 parts, you have a quadratic and a linear piece of the function. Both of those are continuous for all real numbers. So what we need to have happen is that at x equals 1 and x equals 3, the parabola and the lines connect. So the first thing that I'm going to do is take a limit let me turn off my email. There we go. Okay. The limit as x approaches 1 from the left, and that would be x less than or equal to 1 of f of x. And that's equal to 1 plus b plus c. And I'm going to set that equal to the limit as x approaches 1 from the right. And that would be this equation, x greater than 1 and less than 3 of 5x minus 9. And that's going to give us negative 4. So we can take 1 plus b plus c equals negative 4, and write b plus c equals negative 5. And we're going off this page right there. So let's do this. B plus c equals negative 5. Now let's take a look at the same process, but with 3. So the limit, the limit as x approaches 3 from the left of f of x is 15 minus 9, which is 6, and that equals the limit as x approaches 3 from the right, and we're dealing with that piece of the function. And so when we plug in 3 to that piece of the function, we get 9 plus 3b plus c. And so we have 6 equals 9 plus 3b plus c, so that would give us 3b plus c equals negative 3. I'm going to subtract these two functions to cancel the c. I've got a nice little system here. Negative 2b equals negative 2, and b equals 1. Plugging back in to any one of our equations, we get c equal to 6. No, c equals negative 6, sorry. There we go. So now I've got a b and a c, and I'm just going to come back up here and, sorry guys, f of x equals x squared plus x minus 6 for x less than or equal to 1. It equals 5x minus 9. That doesn't change between 1 and 3. And then x squared plus 6x minus 6. So if we're going to evaluate the limit as x approaches 2, 2 is in this center. And so the limit as x approaches 2 of 5x minus 9 is 10 minus 9, which is 1. Okay? All right, now let's do this limit. And so we're looking as x approaches negative 3. And that's this piece right here. X approaches negative 3. That would be when x is less than or equal to 1. And so I'm going to take my limit as x approaches negative 3 of x squared plus x minus 6 over x plus 3. I'm going to factor the numerator into x plus 3, x minus 2. And then as I plug in negative 3, I get my answer to be negative 5. Is f continuous? Yes. Now is it differentiable at x equals 1? So I'm kind of going back up here to these two pieces, one from the left and one from the right, but this time I'm looking at the derivatives. So the derivative from the left is 2x plus 1. The derivative from the right is 5, and I could continue on with the greater than or equal to 3, but I'm not really concerned whether it's differentiable at 3 or not. So the limit as x approaches 1 from the left of f prime is equal to 2 times 1 plus 1, which is 3. The limit as x approaches 1 from the right of the constant 5 is just 5, and those do not equal, therefore not differentiable. The derivative from the left is 3, the derivative from the right is 5, so you don't have a smooth connection there. You probably have some sort of a cusp. Okay, the second question is just your straight up definition of the derivative. This piece right here is f of x plus change of x minus f of x. Notice it's minus the quantity. Some of you missed the sign right there, but really you want this sign. And so our function, we can go ahead and define that as 5 sine of x minus x to the 2/3. And when we take the derivative of that, we get 5 cosine x minus 2/3 x to the negative 1/3. And that takes care of page 1. Let's go to page 2, where we have the data table. We've got a cup of tea placed on a counter and it's cooling, and we're looking at times 0 through 9 and checking the temperature. These are the only values that you're given. You can't make some up based on what you think is going on in between. Notice that I said based on the data in the table, using the times listed in the table. So that was real important that you did that. Average rate of change from 0 to 9. So would be t of 9 minus t of 0 over 9 minus 0. And you have 162 minus 180, which is negative 18 over 9. Negative 2, include units in your final answer, and that would be degrees per minute. Again, using the times listed in the table, what's the shortest time interval to where there must have a temperature of 166.5? And it looks like it would be between 5 and 8. And most of you recognize that. But let's talk about what else you have to recognize. First of all, you have to say that t of x is a continuous function. And how do you know that? I didn't say it, but let's think about t cooling on a counter. Could it possibly hop over one time or one temperature to get to another one? No, it is a continuous function. So we can say, therefore, by the intermediate value theorem, since t of 5 is greater than 166.5 and t of 5 is less than 8, is less than 166.5, there exists a time over the interval 5 to 8 where t of x equals 166.5. And that was basically everything I needed to see to get all 5 points. Okay, now we are finding an estimate of the instantaneous rate of change, aka the derivative, in the change of temperature at t equals 4, time equals 4. So let's go up here to 4. And look to the left, and our change of time is 2. And let's look to the right, and our change of time is 1. And I want where the change of time is closest to 0. So change of time closest to 0 between 5 and 8. So let's find that estimate. It would be t prime of 4 is approximately 164 minus 168 over 8 minus 5. No, I'm not doing that right, am I? I'm doing the problem from up above. My bad. Okay. Sorry. All right, let's go back to 5 and 4, not the question up above. Okay, and we've got a change of time of 1, and we have 168 minus 172 over 5 minus 4. And so our approximation is -4. And I didn't say anything about units, so you were okay to leave them off there. Number 4 was probably the first of a very straightforward question. We want the equation of a tangent line to the graph at x equals 2. So we need two things. We need a point and we need a slope. You have the x coordinate of the point, so let's go in and find the y coordinate of the point, and that's 1. You can go ahead and front load your equation of your line. Y equals 1 equals the slope times x minus 2. Let's take the derivative. We need chain rule here, so 4x squared minus 3 cubed times 2x. There's our chain rule. F prime of 2 is 4 times 1 times 4, which is 16. Plop it in there, and we're good to go to the next problem. Find the values of x for which graph of f has a horizontal tangent. We know that the slope of a horizontal tangent is 0, so let's set the derivative equal to 0. I saw some people go through a lot of pain and agony to expand the original function, or to expand the derivative, or to even expand this. Let's think about how to solve something. When it's set equal to 0, you want it factored, and look at it. It's already factored. So we're going to set x equal to 0, where that's that 2x right here. And then x squared minus 3 equal to 0, and we get x equals plus or minus root 3. So there are 3 values of x for which the graph of f has a horizontal tangent. And next we're going to find f double prime. You really don't have to clean f prime up. It's in pretty good shape. And because you don't have to clean the second derivative up, I think I'm just going to pull the 4 away and do product rule, and in the product rule I'm going to have to do chain rule again. So x squared minus 3 quantity cubed is 1. There's my d2 plus 2, and my d1 is 3. X squared minus 3 squared, again chain rule would be times 2x. There we go. I think that hit it all, and close it off to get the 4 in there. All right, so did I hit them all? Here's 2, and then d1, so the 4. Yeah, the 4 out there is going to make it right, as long as I distribute it through. 5, the bonus. So the reason I said to draw a sketch was only so hopefully it would give you some idea what you were doing. Some of you, I think it helped, others not so much. But there's our point that's not on the curve. It looks like we're going to have a tangent line going here, and one coming in there. So, you know, the fact that I said find the equation of 2 lines, I wanted you to see why you were getting 2 lines. We know that the slope of the tangent at any point on the curve is its derivative. So I'm going to go ahead and take a derivative. If I had graded this as a regular problem, there would have been partial credit for saying the derivative. The other thing you have here is both of these points satisfy x comma x squared, or in other words, x comma f of x, and in this problem our f of x is x squared. And we have this point down here, 1, -3. And we can use good old-fashioned slope, y2 minus y1 over x2 minus x1. And that's the same slope that you would get at that point of x if you put it in the derivative. We had one of these for homework. It was nasty. I came up with this one so it would be nice and clean. We cross multiply. We get 2x squared minus 2x equals x squared plus 3. X squared minus 2x minus 3 equals 0. Factor that x minus 3 and x plus 1. So the two values of x are 3 and -1, and from my picture, it's not great, but you can kind of see we're in the ballpark. I wanted the equation of the 2 lines, so again, we need the points. and the slope. You could use the 1, -3 for both lines and point slope, and a couple of you did it that way that got this right. If you didn't see to do that, then when x is 3, y is 9, and the slope is 6. When x is -1, the y is 1, and the slope is -2. So here we would have y minus 9 equals 6 times x minus 3. That would be one answer. And y minus 1 equals -2 times x plus 1. All right? Hopefully that helps. You will see stuff like that again down the road. All right. And here we go with the last piece of this page, doing derivatives and evaluating them from a chart instead of actually plugging in and evaluating some known function. So the first one is straight up. Do you know the quotient rule? So h prime of x is f low d high minus high d low all over the square of what's below. So that's important. And then plugging in h prime, plugging in 2, we have f of 2, which is -3, g prime of 2, which is -2, minus g of x, or g of 2, which is 5, f prime of 2 is 1, and you have 6 minus 5, which is 1, over, I believe that's 3 squared, or -3 squared, and your answer is 1/9. And of course, if you had this written, you got full credit as well. J is a, I would say, straightforward chain rule. J prime of x is f prime of g of x times g prime of x. So j prime of 2 is f prime of g of 2, but g of 2 is 5, so I got to plug that in, times g prime of 2, which is -2. F prime of 5 is 7, so 7 times -2, which again, if you left it, that was fine, or if you went to -14, that was fine too. C was also chain rule. It was just presented in a little different format. K, if we write it so we can really see what's going on there, is f of x raised to the 1/2. So k prime would be 1/2 f of x raised to the -1/2, there's our chain rule, times f prime. K prime of 5 is 1/2, and it would be 1 over the square root of f of 5, and I believe f of 5 is 2, if I remember correctly. No, it's 4, sorry. So 1 over the square root of 4, and then times f prime of 5 again is that 7 we had from above, and so that answer is 7/4. Y'all had pretty good luck with the implicit differentiation. I know it was the last thing we did, and it stuck with you, and I was really pleased to see that. But I'm still going to do it. 9y squared dy. Here's some product rule that I'm going to need. So minus 2x dy plus y -2 dx plus 2x dx equals 0. And at that point, I'm done with the calculus. I have taken the differentials of each variable. Now I want it, because this says with respect to x, I wanted to put a dx. Let's kind of clean that up a little bit. The first two terms have a dy dx in them, so I'm going to factor that out. 9y squared minus 2x equals 2y minus 2x. And our final answer here is dy dx equals 2y minus 2x divided by 9y squared minus 2x. Last page. If I can get it to move. Wow, is it going to freeze? Oh, there we go. Thank goodness. Okay. For what values of x over the open interval 0 to 2 pi will the derivative of g fail to exist? G is the product of f and cotangent. It says f is differentiable for all x, so I'm not worried about f. I'm just concerned about cotangent. So let's take a look at cotangent of x. Cotangent of x, which is cosine over sine, is not continuous, therefore not differentiable when sine of x equals 0. And over this open interval, the only place would be pi. We could also, if we're talking about differentiable, then we probably should go ahead and take a derivative. We're going to need it here anyway. So let's do the product rule. G prime of x is f. The derivative of cotangent is negative cosecant squared plus f prime times cotangent. And so I do have another function to consider, this negative cosecant squared, but negative cosecant squared is the same as negative 1 over sine squared. So I've got that same denominator of sine, so I'm not going to pick up any more points of where the function isn't differentiable. So I can just leave it as x equals pi. So let's finish up. Last but not least, g prime of pi fourths is equal to f of pi fourths. F of pi fourths is 4 times negative. Okay, cosecant is the reciprocal of sine. The sine of pi fourths is 1 over root 2. The reciprocal of that is root 2 squared. And then f prime of pi fourths is negative 2. And the cotangent of pi fourths is 1. And so again, you could leave this, but we have 4 times negative 2, which is negative 8, minus 2, and I don't know why I got negative on that, I'm sorry. Minus 2 is 6. I hope I feel better. I hope I see you next week. I hope you have a great weekend, and please come see me if you have more questions.